Hello, discrete math fans. Let's go through a few special functions that will come up from time to time. The first one is called the identity function. So given a set x, the identity function, which we'll call I, or sometimes I sub x, is a function that maps x to x. It's the function that satisfies I of a is equal to a for every a in the set x. What a boring function. All it does is take the input and spit that input right back out. All right, what about when we have a sequence? Now we can actually think of this as a function that maps the natural numbers to the real numbers. So for example, if we have a sequence whose nth term is defined by the formula a sub n equals minus 1 to the n over n squared plus 1, then we can really think of it as a function f of n is equal to minus 1 to the n over n squared plus 1, where the function f goes from n to the real numbers. So the input is the index in the sequence. All right, multiplication. So if we multiply real numbers, that's a function. So multiplication is a function that takes as its input two real numbers and outputs a single real number. So we can think of the input to multiplication as an ordered pair that comes from r cross r. So we can define the function m, this is the multiplication function, which maps r cross r into r by saying that m of a comma b is equal to a times b. Now we can also define functions on power sets of other sets. All right, let's create a function that maps from the power set of a, b, c into the whole numbers by saying that for every x that's in the power set of a, b, c, so when we say that x is in the power set of a, b, c, that means x is a subset of the set a, b, c. We'll just say that f of x is the number of elements in x. All right, let's make an arrow diagram to illustrate f. All right, so at first you think that it might be difficult to draw an arrow diagram because the codomain, which is the whole numbers, has infinitely many things in it. But we're only going to be mapping to the numbers 0, 1, 2, and 3. In other words, the range of our function is finite. So then over on the left side, we just list all the elements of the power set of ABC. So that's all the subsets of the set containing ABC. And then we map those over to the codomain to the number that represents how many things are in that set. So the empty set gets mapped to 0 because the empty set has nothing in it. And then the sets that are singletons, the set with A, the set with B, the set with C, those get mapped to 1. The only thing that gets mapped to 3 is the set containing ABC. And so here's an arrow diagram that illustrates the function that maps a set to the number of elements in that set. Okay, that's all for now.